So today we are going to talk about one of possibly the most interesting topics that you'll encounter in Linux administration class. And that is the configuration of SUDO, or account elevation. Now, in front of you is a quippish little cartoon which gives the essence of the SUDO command, which you've encountered already in your interaction with Linux Mint, our operating system of choice. So you can read the little cartoon on your own and make the connection, which I'm sure you'll see. Now, we have been using Linux Mint, which is a specialized distribution under the Ubuntu family of Linux distributions. And in Ubuntu, the root account is disabled. You've probably come to that realization this far. As we have discussed, Ubuntu and its derivatives were mainly designed to be user-centric rather than techie-centric. And with that in mind, some of the mechanisms that are in a plain vanilla Unix or Linux system that can get a general user into trouble, including the root account, have been mitigated. So when you have Ubuntu Linux computers and you need to do specialized or protected tasks, then that has to be done with SUDO so that you can act on behalf of the root account. What you're going to soon find out is there is a lot more to SUDO than initially meets the eye. You've used SUDO in front of commands like apt-get or tail to access either files or actions that would not be normally accessible to the general account user on your system. And so far, you've sort of just done that, out of hand to brute force your way into these upper level or account elevation actions. But in reality, the entire SUDO architecture offers a whole lot of customization. And if you're an account administrator or a Linux system administrator who really understands the power of SUDO, you can be very valuable to your organization. The first thing to know is that the system is powered or configured through a SUDOERS file. And that file is located underneath the etc directory path, as is many of the other configuration items that we've been learning about. So let's look under the etc directory, and we will see that there is a file up here, SUDOERS, and you'll also notice there is a subdirectory, SUDOERS.d. So again, that's following a lot of the nomenclature and formatting that we've seen with other items in the Ubuntu system, where a subdirectory for a certain function or process has that .d extension to it. So the SUDOERS file we can take a look at. And we'll pipe it to more. So the SUDOERS file itself, as you can see, cannot be displayed or catted by the regular user. So we will have to use account elevation itself to look at that file. And I will use my password. You will use yours. And here we have the SUDOERS file. We can see that there are some comments in the file. Those are the lines that would begin with that hash mark or tic-tac-toe sign. And we can see right off, this file must be edited with a special command, vi sudo or vis sudo, some people say. And that also has to be run with account elevation. So we can see that this sudo has to be run as root. There are some setup variables. Those are denoted by the keyword defaults. And there are then the ability to do some aliasing. These are just markers, so there could be host aliases, user aliases, command aliases. And then we finally have a user privilege specification. And it says that the root user, which we know we don't really have a root user on Ubuntu, but it looks like these keyword all basically means root user can do anything. We're going to talk in just a second about what these different field areas mean. Each one has a meaning, and we'll take a look at that. But I want to hit more so that you can see the end of the file. And the very last specification in the file says include directory is /etc sudoers.d. That means that you, as an account administrator or system administrator, can add additional specifications to customize your system, and you put those in files that are inside of this sudoers.d subdirectory. So we'll be taking a look at that momentarily, doing an example so that to help you clarify that in your head. Back to the general format of the SUDOERS file. It contains rules that apply for the users on your system, telling the system for what users can use account elevation for what purposes. So sudo is a way to elevate the privileges of a certain account to just perform certain tasks. And that's what we're going to learn about. You may already be aware that in order for a user to even use sudo, the user has to belong to the sudo group, or that user must be specifically called out in a configuration file. You may not be aware of that, but let's take a look again at let's look at me. Who am I? My account name on this particular system is Deborah M. Okay. And let us ID, and we will find out that this particular account is a member of many groups, but you can see that the account is a member of the SUDO group. You can do the same for whatever account you are logged in on your own system. But by virtue of the fact that Deborah M is a member of the SUDO group, I have been able to use account elevation for certain purposes. And we're going to find out more about those purposes as we move along. Why have the architects and engineers of Ubuntu created this SUDO command system rather than just playing along like the original Unix and Linux distributions and have this root account? Well, SUDO offers us the capability to give certain privileges to only certain accounts. So it's more granular than root, which root's just like the shotgun method. Once you are in that root account, you can do anything constructive or destructive. The second thing about SUDO is that logs are kept of the actions taken by users who use SUDO. So there's an auditing mechanism built in. And we can look at that in the var log subdirectory in the auth.log file. Let's take a look at that. Let's look at a tail of var log auth.log, and we can see the very last line, November 13th, which happens to be the same date I have on my system clock. So right now, just a few seconds ago, a command user bin tail was issued to look at the auth.log file, what I'm looking at right now. And a little bit before that occurred, then the user on the machine named Deborah M-VirtualBox opened a session for user root. So there is a good audit trail of the user accounts who have been using account elevation. This is something that then you, as the system administrator, can keep an eye on. And if there is some account elevation going on that looks out of sync with your expectations, that is certainly something to investigate. So var log auth.log is the log file under Linux Mint where one can find information on uses of SUDO. We are going to configure our privileges or our rules in the file etc SUDOERS, or in a file that exists under the subdirectory /etc/SUDOERS.d. We must edit with a special program, VI SUDO, which will edit the file in a safe fashion. It prohibits bad formatting to the file, won't allow it to be saved so that you don't completely wreck your system. Secondly, it locks that SUDOERS file so that multiple simultaneous hits cannot occur where something overwrites another user's edit of that file, and there are some basic checks and balances in this way. How you issue a VI SUDO command is with the format sudo space VI SUDO space -F, so a flag, and then the name of the file that you propose to edit. So if you're editing the main SUDOERS file, thus you would use just the name SUDOERS. But in general, the best practice is if you want to create new customizations, then create new files under that SUDOERS.d subdirectory. And we'll do a little bit of that in a moment. But first we need to understand the format of the rules. We saw moments ago when we looked at the SUDOERS file, there were some placeholder for aliases. Aliases are basically shorthand names for longer things. So if I wanted to specify a command that had a very long path name, I might create a shorthand alias for it. And then the second type of entry in the SUDOERS file, or a file in the SUDOERS.d subdirectory, are user specifications. And those are the rules. Rules are applied in order. So those in the SUDOERS file, then in an order chosen by the system in all the files that are in the SUDOERS.d directory. There's a rule or a edict that the last match wins. So when there are multiple matches for an account or a group name, whichever one the system encounters most recently, or last in the sequence, is the one that is permanent. That's just so that you can keep in mind that if there's some crazy things happening on your system, or you just configured a specification and now they're not working as you thought they might, that's a clue to go back and check all of your SUDOERS.d files and make sure there isn't some conflicting rule that you may need to comment out or delete, so that your expected rule is the one that matters. There are those 4 kinds of aliases: user, run as, host, and command, and they are named as you see on the slide. You must name them exactly as they are written here, because That is how they are recognized by SUDO. And let's take a look at the formatting. In general, the rule or specification is there to determine what commands a specific user account may run and who they're elevating to. And in short, we usually elevate to root level, but that's not always the case. And you can also specify on what specific hosts that this elevation holds true. So if I wanted to create the ability for a specific account on my system to only allow a privilege from my exact computer and no other terminal attached to the server, then I could do that. By default, commands are run or elevated to the root level, but that can be changed on a per command basis. So the general format is what we see in red. So who and from where can a command do what, and running at what level. So that this run as spec, think of it most of the time to be root. Okay. But in general, it can have a user list that may be the printer username, or UUCP for copying across, the communications channel. Let us take a look at an example that might hold true. We've got user Bob, and we're going to say that Bob can run any command from any location and elevate to any account. So we're just given sort of free reign to Bob. Okay, and again, you can look at the top line to see the meanings of each of these positions. If you put a % in front of a name, that tells SUDO that's not a username, but a name of a group. So if I wanted to give privilege to a group of administrators who happen to be in an admins group, I would do it with this %admins. The run as specification that we alluded to moments ago determines either a user or user group combination that that our account can elevate to. And again, in most cases, we're going to use the specification all::all, which just says you're going to get almost, blanket elevation. But here's an example. Let's take a look at it. We have user Alan, and he may run any command over at the far right, and he may run any command as either the root user or the bin user, and those can be in the operator or system groups, and Alan can run those from any originating computer. So again, to remind you of the meanings of the positions, we have the specification in red here that you can refer to. The second example has a user account named TCM, and this example has just a little more detail to it because we learned that TCM can run the tip command, the CU command, and the minicom command as the group dialer, but only from the Boulder computer. So below would be an example of an account elevation, SUDO, and specifying the group dialer, user bin CU. That is if we were running under the account TCM. This would be a valid command that would work, and we would be asked for our password, and it would have to be the password of the TCM account. Here's a little example to demonstrate the use of SUDO configuration. We have an account named test, and we are modifying the user to add that account to the group SUDO. Okay, so if you wanted to do this on your own system, you can first create an account named test. Let's see if we have an account named test. Doesn't seem that we do. And we will use the add user wizard, and we want to add the user test. So I have to account elevate, and for this user, pick a password that you're going to remember, and we'll just say you know, Harry Foster, and we don't really know the phone numbers. We don't have to add those in. And is the information correct? Yes. Okay. So now I have a user account named test. I can convince myself of that by looking at the password file and see that the last entry is our test account. And now what do I want to do? I want to modify that count to add it to the SUDO group. So let's do that. SUDO user mod -a, and put it into the SUDO group and the test user. Now, if I ID test, I see that the test user is in two groups. The one that is equal to the user account name and the SUDO group. Now, to convince ourselves that that test user does indeed have these elevation privileges, we can use the SU command to change our identity to that user. So let's clear the screen, and we must now enter the password that you just configured for the test user, not your regular user account. And we can ID just ourselves, and we can see that now I have the identity of the test user. Does this user have the account elevation privileges? Well, let's first just try to tail SUDO. Oh, SUDO is a file that has additional protections. It cannot just be looked at by any old Tom, Dick, Harry, or test. So can we account elevate and look at SUDO? Well, now we need to enter not the password for my normal user account, but the password for the test account. And now I am able to see the contents of SUDO from this account test that I just created. So you can see that we have conferred some elevation privileges onto another account in our system merely by adding that account to a group that already had elevation privileges. That was the group named SUDO. Let's move on. Just as a review, from that test account, the question is, can you perform other SUDO privileged commands? And the answer is yes. Pretty much anything that our regular account that was using SUDO all along could do, I could also do from that test account. But what if we wanted to restrict the powers of this test account? Can we do that? Let's think about stuff we just went over. When multiple entries match for a given user, they are applied in order. And when there are more than one entry, it is the last one that is the directive. So if I want to restrict the privilege for a specific user or group, we need to add a new directive far down the list, or we need to comment out the other conflicting directive. There is a file in the SUDOERS.d directory called the README file. Let's look at it. So, etc SUDOERS.d, and there is the README file. You can look at it on your system. As it stands, it is a file that only contains comments. So you can see that every single line has the hash mark at the beginning, meaning that it is commentary. The file tells us that that line that we saw at the end of the SUDOERS file, the include dir command or instruction, tells the system that new files that exist in this subdirectory, sudoers.d, will be processed then in order to read more rules. Okay. And that you should note that there has to be at least one file in this subdirectory, and when you install Linux Mint, the README file is there already, and also that all files need to have the read-write for user, or actually read-only for user, I'm sorry, and read-only for the group as well. So they have to have the chmod of 440. Okay. And I direct your attention to the slide as an additional explanation of what that mode 0440 means. Let's go through a little example for configuring account elevation in a more granular way. The first thing that I like to do is copy that README file to another file. The name here happens to be SUDOERS1, but that name is not cast in stone. It can be something descriptive to the account configuration that you are putting in place. And after that new file is created, and basically by doing the CP of the README file, you're going to create your new file with the correct 0440 permission mask. Then you can edit the file with sudo vi-sudo -f sudoers1. Let's do it. Okay, so here we are. We're going to copy README, and I'll just use the example. Copy it to SUDOERS1. Oh. It's a special file. We have to use account elevation. Okay. So now we have in this directory 3 files that existed there already, and the SUDOERS1 file that was just created moments ago. And then we want to sudo vi-sudo and then -f sudoers1. And we can see that we actually are in what looks like the nano editor, which apparently is the default for this system. You might like nano. I do not. So what I am going to do is use the defaults keyword, and I am going to set my editor to the path to the VI editor. and that is going to be user in VI. Now I can, since I'm not really used to Nano, I have to look at the bottom here. So I want to write out with Control O, and okay, so I did successfully add this one line called defaults and set the editor. Now I'm going to go back and edit again. And now we see that VI SUDO opened our SUDOERS 1 file in the VI editor, which happens to be my editor of choice for the command line. If you like Nano, then don't add this line to your SUDOERS 1 file and just march on as you see fit. But now I can use the VIO command, opening up a new line, and I can add my test account and say, well, from all locations, I want to allow tests to run as anybody, but now rather than giving tests this free reign to do anything, I want tests to only be able to run the tail command. So the tail command is in user bin, and then there is tail. And now I should be able to use the write and quit or Shift ZZ, and I am finished editing SUDOERS. Now, if I want to look at the contents, I can do that and see that I've added these two specification lines to my file. So the question now becomes, is the test account able to do just blanketly everything, as was true with only adding it to the SUDO group, or have I restricted that account further? Let's do some checking on our test user, and you can see that I am still logged in as test, and test is a member of this account elevation group. And we also just added a restriction for test, but test being a member of the SUDO group and that restriction might, clash with each other. So I am going to exit so that I am back at my regular account, and I am going to use a command, group PASSWD, and the -D flag to remove the user test from the group SUDO. So now the test user's just a average little old account again. And let's change our identity back to test. we are in the home test directory. So let's go back to that etc SUDOERS.d. Look what's there. Try to cat the README file. The permission is denied. Let's try account elevation. Sorry, the user test is not allowed to execute bin cat on README. Now our test account doesn't have that blanket account elevation privilege, but we did add a granular rule to allow test to use the tail command. So let's try that. sudo tail readme. And that still works. So you can see that when you combine all the capabilities of granularization using the complete SUDO architecture, you can really wield particular control over your system, adding security as well as sort of a coddling for your users, only allowing them to do what makes sense for them particularly. Here's another example from Linux Mint. And in this case, it's an example of creating a command alias. So the command alias is the word update set to this very long path to a Python program. And now we allow all users to, without entering a password, do the apt updates from any machine. So on your Linux Mint computer, go ahead and cat the etc SUDOERS.d mint update file, and you'll have some clarification there. Here are some additional resources. There's the sudo man page and an article on the file format. I urge you to practice with it, experiment, and I think you'll find out that there's a whole lot you can do with SUDO.